Okay, Bismillah Rahman Rahim. Today is lecture number 1 of the course Irrigation Engineering. So today, first part of the lecture, we will discuss about the course outline. Now, the course aim, why we need to study this course. So the aim is to develop understanding among students towards water resources, hydraulic structures, and irrigation systems, salinity and water logging, and water management practices. So the basic purpose of this course is to develop the understanding related to water resources, what are different types of water resources. So as you have studied so far in the previous courses, especially in hydrology, that we have the rainfall which is coming down from the atmosphere to the surface of the earth, and then it appears as surface runoff or infiltrates into the ground surface and joins the aquifers. So we will study about the different resources of water and hydraulic structures. Since we have water flowing in the rivers, so we need to construct the dams, which for example you can see here. So you already know that dam is a multi-purpose hydraulic structure. We have river water that is variable throughout the year. So if we have enough quantity of water flowing in the river and the discharge remains uniform throughout the year, then we don't need to construct dams. So we just regulate the river flow by construction of dams. When we have high flows in the river, so we store that water, and during the low flows in the river, we release that water to meet the water demands. And those water demands can be domestic demand, industrial demand, irrigation demand, hydropower production. So these hydraulic structures that we are going to study, dams, we will study in detail. But beside that, we have other hydraulic structures that we have to study. For example, we take the water from the dam to the agriculture fields, farmlands. So we have to provide a network to carry the water from the source to the point where it is to be delivered to the crops in the fields. So for this purpose, we have to provide different hydraulic structures in the form of canal outlets. For example, we supply the water to the agricultural land. We need to measure the quantity also. Similarly, we have cross drainage works. For example, we carry the canal, as you can see here, canal, which is artificial channel that carries the water. So if this canal, it crosses a drain or for example a river, so then there are three possibilities. Either we have level mixing, that this water is allowed to mix with the river and then again it is withdrawn on the other side, or it is carried above the river, which is known as aqueduct, or it is carried below the river bed. In that case, it is known as siphon. Similarly, if we have the natural topography such that there is significant change in the slope, so then in that case we have to provide what is known as canal falls. For example, we have the drop structures. let's say we have this is the natural surface level, and then there is a sudden change in the level. So then in that case we have to provide drop structures. Clear? So that we call as canal falls. So we have to study different hydraulic structures and irrigation systems. Now we have to supply the water to agricultural land. So there are different types of irrigation systems. You see here in this picture that we supply the water. You see here this is kind of furrow irrigation. You can see here narrow ditches, and the water is supplied. In the second picture you can see that we have what is known as a sprinkle irrigation system, in which you can see that the water is sprinkled over the crops. And in this picture you can see that we have a network of pipes where the water is directly provided to the roots of the crops. So you can see here that we have different types of irrigation systems. So we will learn that what are different types of irrigation systems and their efficiency in terms of supplying water to the crops. Similarly, we will study about the salinity and waterlogging. Salinity means the different salts which are present in the soil. One way is that when we supply the water, for example, you see here, so this water, not all 100% of water it is utilized by the crops. So this water, it infiltrates into the soil and then it percolates through the soil profile. So it takes the salts if present in the soil at the surface. So it means that this water can also help in removing the salts which may not be beneficial for crops. This is one way of we can deal with salinity. But on the other side, if the water table is very high and the same salts can come up to the root zone and top of the soil and make it less productive. So we will study about this salinity and waterlogging. Waterlogging, when the water level, the groundwater level that raises to the surface of the ground, and eventually the land productivity that is adversely affected. The simple example is that when we constructed the Tarbela Dam, so in that case, because of the seepage of water, as you already know that Tarbela Dam is the largest earth and rock-filled dam in the world. There are different types of dams, but earth and rock-filled dam, the largest dam is Tarbela Dam in the world. So because of this dam construction, there is seepage of water, and as a result of that, the water table raised, and it adversely affected the land productivity. So this phenomena, this is known as waterlogging. So we will study what is salinity and waterlogging, what are the causes, and how to deal with such problems, and water management practices. So Water management practices means that how to increase the storage capacity of water for useful purposes. That is, we need to construct more dams in order to store the water and then use the same water for meeting different demands. Improving the infrastructure of these irrigation systems, which are in the form of weirs, barrages, canal outlets, cross drainage works, to improve its working and operation. Similarly, water management practices include how to produce more food with less water, how to better manage the surface water, and how to better manage the groundwater for make it more useful in meeting the water demands. So this is the course aim, to develop understanding among students towards water resources, hydraulic structures and irrigation systems, salinity and water logging, and water management practices. So we will study about all these in detail in this course. Now, course learning outcomes. CLOs, upon successful completion of this module, students will be able to define basics of irrigation and water resources engineering. So as we will cover different topics related to irrigation systems, the different hydraulic structures, the problems that we face in the form of salinity and water logging. So you should be able to define basics of irrigation and water resources engineering. The second CLO is to describe the different methods, principles, and processes involved in irrigation. So you should be able to describe the different methods, for example, of irrigation, as I show you here. These different methods of supplying water to crops, you should be able to describe them. The principles and processes involved in irrigation. For example, you see here, we have this canal. We should be able to describe the different theories that will be used to design these irrigation canals, the different processes involved in irrigation. So in this case, the different hydraulic structures that we have to study, as I explained, in the form of the dams, weirs, barrages, canal outlets, canal falls, cross drainage works. So you should be able to describe all these that involve in irrigation. And the third CLO is to apply the knowledge of irrigation engineering to solve basic and complex problems. So the basic knowledge that we gain in this course, you should be able to apply that knowledge in solving basic and complex problems. For example, if we have to develop an irrigation project, so you should be able to apply the knowledge gained through this course, how to plan, develop, and operate that irrigation project. And that would mean that you identify the source of water based on the crop water requirements, that we have to determine what sources are available. Is rainfall sufficient? If not, is surface water in rivers available? If that is not sufficient, can river water be supplemented with groundwater in that area? And then how to carry that water to that irrigation project to meet the crop water requirements and the infrastructure needed for successful operation of that irrigation project. So these are the CLOs, the course learning outcomes that we should be able to achieve after completion of this course. Similarly, these CLOs, then they are linked with the PLOs, program learning outcomes. So you can see here that these CLOs will contribute to PLO1 and PLO2. Teaching and learning activities. So course learning outcomes, the CLOs, that will be achieved through a combination of the following teaching strategies. There will be instructor lead presentations. There will be classroom discussions in the form of questions and answers. We will study different topics that will involve practical problems, numerical problems. So we will solve examples in the class to determine how to apply the theory. Then there will be quizzes to evaluate you how much you are learning from the instructor presentations and classroom discussions and examples that are solved in the class. There will be assignments, take-home assignments, where problems will be given to you for practice. Then there will be midterm examination, and we have end of the course final comprehensive examination. So these are the different strategies through which the course learning outcomes of this course that will be achieved. Now these program learning outcomes, which you must have good idea so far. These PLOs, the first one is engineering knowledge, which is linked here. You can see here PLO1 here and PLO1. So PLO1 is engineering knowledge. So an ability to apply knowledge of mathematics, science, engineering fundamentals and an engineering specialization to the solution of complex engineering problems. So you gain the knowledge. This is what it says. And PLO2 is problem analysis. An ability to identify, formulate research literature and analyze complex engineering problems, reaching substantiated conclusions using first principles of mathematics, natural sciences, and engineering sciences. So these PLOs are written in general terms because these are applicable to all areas of science and engineering. So the course learning outcomes that will be achieved, their contribution will go to this PLO1 and PLO2. As you already know that now in the OBE system, outcome-based education system, you will get actually two transcripts. One is the relative grading, and the second one is the transcript which will mention these CLOs and these PLOs. So the CLOs of this course, the percentages that will be obtained at the end of the course after all the assessment activities, they will contribute to these PLO 1 and 2. We have other PLOs also, for example, design development of solution, investigation, modern tool usage, engineer and society, environment and sustainability, ethics, individual and teamwork, communication, project management, and lifelong learning. So other courses, they will contribute to one or more of these PLOs. Now the course syllabus. So in the first part of this course, we are going to study introduction to water resources. So in this we will study what are the different sources of water. So primarily we have three main sources of water in the form of rain, and we have surface water and groundwater. So we will study about this in the context of Pakistan also, that what are the different water resources available for irrigation in Pakistan. After this, we are going to study irrigation. What is irrigation? What is irrigation engineering? What are the different methods of irrigation? Irrigation water requirement, how to measure that, irrigation water quality, and the different irrigation systems such as, for example, furrow, border, sprinkler, and trickle irrigation systems. So in the first part, we will study in general about the water resources and water resources availability in Pakistan. And then we will start with what is irrigation and the different methods of irrigation we will briefly discuss. Similarly, we will be briefly discussing this irrigation water requirement. For example, for different crops, how much water they need. Crop water requirements. So very briefly, we will discuss that. Similarly, the irrigation water quality, you already studied environmental engineering about the water quality. And these irrigation systems, so we will briefly explain. Now in Pakistan, we have the conventional irrigation methods that still are in use today, but in the developed countries, they are using sprinkler and trickle irrigation systems. You can see here, if I go back to here, you can see that these are the conventional methods. For example, free flooding. You just flood the agriculture area with water. So the problem here is that the water which is supplied, not all used by the crops. So consequently, the irrigation efficiency that is low means that you supply more water but less is used by the crops. So here we have enormous wastage of water here in the conventional methods. So we will study in Introduction to Water Resources that water, the freshwater resources, we do not have unlimited water resources. and also the distribution of water throughout in space and time, that is not constant. So in some parts of the world we have more water available, in some parts of the world less water available. So accordingly, then you have to manage the water to meet the demands. So in Pakistan, because we are blessed with glaciers in the north, and during the summer time, the melting of glacier contributes to the flow in rivers. So that's why so far we are using the conventional methods of water supply for agricultural lands. But in developing countries where they are more cautious about the use of water, they are using the irrigation methods which are water efficient. For example, we just supply the water that are required by the plants. So in Pakistan, still it is not at greater level the use of these. For example, this is the sprinkler system. We are sprinkling the water over the area, or this system here, which is the drip or trickle irrigation system, a network of small pipes over the agriculture area, and we directly supply the water in the form of these drops, water drops, drip irrigation system. So the reason behind is that it is, although less efficient in terms of water usage, but it is more convenient. Convenient in the sense that we just flood the area with water. No maintenance, etc. required here, because you see here, operation of these systems will require the cost of installation, then operation and maintenance. So this could be a reason, because of to operate also these systems you need the skilled labor. The farmers need to be trained. So this could be the reason why in Pakistan we are using conventional methods of irrigation. But anyhow, because of the water crisis which are looming around the world, we need to adopt more efficient irrigation systems. So this is what we are going to study in detail in this topic, Claire. Then we will study about canals. So as you already know, that canal is artificial channel that supply the water, that carry the water. So we will study about the design of irrigation canals. We will design them, and as per your syllabus, we will apply the Kennedy and Lacey's theories to design the irrigation canals. We will also try to study about the irrigation canals, because you see the canals can be erodible and non-erodible. So we will try to cover both types. We will study about the canal lining, because the water that is carried in a canal can infiltrate into the earth, soil, so water is lost. So in order to prevent these losses of water, we can provide lining for canals. And for this we have to provide the material that is impervious to prevent loss of water. So we will study canal lining, what are its advantages and types. Also, maintenance of irrigation canals. Because when canals are constructed, so these carry water, and the water carry sediments or other debris or waste material, and these can get deposited in the bed of these canals and ultimately reduce the discharge carrying capacity of the canals. So this maintenance of canals for efficient water supply, this is very important. And you might have frequently heard in the news that especially in Punjab, the cleaning of irrigation canals, this is done every year to remove any waste materials that are deposited because they adversely affect the water carrying capacity. So we will study about maintenance of irrigation canals. Next we will study diversion headworks. So how we divert the water from dams or rivers. So we will study about the canal headworks. There can be different types: storage headworks, diversion headworks. Storage in the form of the dams, diversion that we raise the water level and just divert the water, for example, weir and barrages. So we will study about the selection of their site and layout for the weirs and barrages. When we have canal headworks, what are their different components, the associated structures, and their functions? As I said that canals, they carry water, so water may carry sediments. So measures adopted to control the silt entry into canals. We will study how to control the silt entry into the canals, because the reason is that these silts that can deposit in the canal beds. So for this purpose, we will study silt ejectors and silt excluders. These are the measures that are adopted to control the silt entry into irrigation canals. We will study about different irrigation works. Here we have introduction to canal and regulators, how we regulate the flow into the canals, canal head regulators. We have different falls. As I said that if the natural topography is such that there is a fall in the slope, so at this point we have to provide what is known as canal falls. For example, you might have studied in hydraulics course about the chutes, drop structures. So we call them as canal falls. Flumes, we have open channel that carries water at or above the surface of the ground. Similarly, we will study about the canal outlets. These canal outlets are used to measure the discharge, the quantity of water, to control the flow of water to the agriculture fields. So these are known as canal outlets. And cross drainage works. As I said that if we have, let's say, this is the canal and the water is flowing in this canal and it has to cross a drain or river, So there can be three possibilities, that either we have level crossing, so this water can cross and then again the water is withdrawn on the other side. So this is known as level mixing. Or the other option is that this canal, it can be carried above the drain or river, in which case it is known as aqueduct. Or it can be carried below the drain, so that is known as siphon. So these are collectively known as cross drainage works. So actually these are small chapters: canal falls, canal outlets, cross drainage works. So we will study about the types and their functions, and monitoring of flows, telemetry system, how we monitor the flow of water. So you already studied. The simple example to understand is, for example, you studied the stream flows in your hydrology course. So we measure the discharge at different points along the river or stream. For that purpose, you studied the different methods. For example, you studied how to divide the cross-section of the stream into different verticals, and then you use the mid-section method, mean section method. You calculate the area and the velocity you calculate with the current meter. So if the depth is shallow, we calculate the average velocity at 0.6 times the depth of water, or the 2-point method where you use the 0.2 and 0.8 times the depth of water and then average. So you can develop the rating curve, which is the discharge versus the depth. Now we need to measure the stream flow every day for efficient monitoring. And the reason is that, for example, if from the level we know that what is the situation of water in the river, the discharge is reducing or the discharge has increased, or in case of floods, at least we know that what is the discharge at this point. That's why stream flow measurement is very important topic. So now to measure the discharge this way every day, it's very difficult. And if we have so many points along the stream or river, so what we do instead is that we can develop a rating curve that you studied in hydrology. That is the discharge versus the depth of water at a gauge section. So you just need to measure the depth of water, and you can use the different gauges, manual or automatic, and then you can use the rating curve to estimate the discharge at that point, that cross section. For that we can also have telemetry systems, automatic systems. So the depth is recorded and then it is transmitted to the control room where the data is processed and stored. This is exactly similar to say that, for example, you measure the rainfall, so we have the rain gauge. So you collect the quantity of water and then you calculate the depth of rainfall. But for example, you studied the automatic gauge, rain gauges, for example, the tipping bucket gauge, where it can calculate the depth of water automatically. It can be stored or transmitted to the control room, which can be located away from the point of measurement. So we will study some introduction here, monitoring of flows. We will also study about the water logging and salinity. So as I already explained, we will study that what are the causes and effects of water logging and salinity with special reference to Pakistan. So in Pakistan, as I already give you the example, in our province, After construction of the Tarbela Dam, the water table raised in the adjoining areas due to seepage of the water. So this contributed to waterlogging. When the productivity of the land is adversely affected by the high water table, this is known as waterlogging. And if the soil contains salts which are not beneficial for the crops, that is salinity. So we will discuss with reference to Pakistan what are the causes and effects and how we can deal with these problems that we call as reclamation methods. Soil reclamation. You reclaim the soil or reclaim the land from these problems. So when we constructed the Tarbela Dam, the water table increased. It raised to the surface and it adversely affected the productivity of the land. So for that, we actually need to provide drainage network in order to drain that water to lower the water table and increase the productivity of the land. So we will study, you might have heard that in Mardan and Sawabi, you see we have scarp schemes. We have these scarp schemes. This means that salinity control and rehabilitation project. So the lands which were affected because of the dam, we store huge quantity of water and the seepage, and so because of this we have these scarp schemes. So we will study about them in detail and what we did in these projects to deal with these problems of waterlogging and salinity. And as you see that when we supply the water to the crops, not all of the water is used by the crops. So that is why for draining the water, we need to provide a drainage network in the irrigated areas so that the water drains, because we need the water at times. For example, when we feel thirsty, we drink water, but if you continue to drink water, it may have adverse effect on the health. So similarly for plants, when they need water at the right time and in right quantity, we should supply the water. Other than that, then it will have negative effects on the plant growth. So that is why drainage engineering is a subject in itself. So we will study some introduction about the drainage network in the irrigated areas. And then we will study about the dams. What are the different types of dams? The different forces acting on the dams. What is the criteria for site selection? So in this case, we will study the different types of dams and the forces acting on them, stability analysis. We will also study some introduction to the reservoir sedimentation and delta formation. The water which is stored in the reservoir carries sediments and then they are deposited, and ultimately the storage capacity that is affected. So these terms, these are related to the dams. We will study in detail, because the water which is stored behind the dam can move in the form of waves. Clear? So it can apply some load on the dam, wave run up and set up. As I said, that dams on the one side have positive effects we store the water that can be used for different purposes: domestic and industrial water supply, irrigation water supply, hydropower production. Also, the stored water, if seepage takes place, then the groundwater aquifers are recharged. Similarly, when we have floods in the rivers, we can store the water in the dams and protect the downstream communities from the effects of floods. But on the other side, the dams also have the negative effects, because we regulate the flow of rivers, so the natural ecosystems, they are affected. Also, you are storing the water, so it has impact on the environment. Water, when it stays in an area for some time, it can result into spread of diseases. So we will study introduction to environmental impacts of dams. So this is the course outline, the course syllabus that is given in the contents that are defined. These topics that are arranged in the weekly schedule. So this is how in each week we will cover these topics. So there will be 7 working weeks. Previously used to be 8 working weeks before the midterm examination and 8 working weeks after the midterm examination. But now we have 7 working weeks. After that we have the midterm, and then we have 8 working weeks before the final term exam, making a total of 15 working weeks. So we will try to cover these topics in detail. Assessment task activities. So we will have home assignments and quizzes. So that covers 20% of the 100% weightage. Since this is a 3 credit hour course, so there will be 3 in-class tests and 3 take-home assignments. So if online classes continue, then we can have online quizzes. And we have 20% weightage given to the midterm exam. So if we have physical exam, 1.5 hour written exam, and the final term, the weightage is 60%, and it is a 3 hours written exam, and it will cover the full course. That's why the percentage is more. So the final grading, that is relative. We have relative grading for this course, but remember the CLOs that you will score on the CLOs, course learning outcomes. So that is absolute, that is not relative. So you should know that minimum score on each CLO to pass, that is 40%. If any score on any CLO that is less than 40%, that CLO is failed. Even though you may have A-, B+ grade, but it can happen that one of the CLOs or 2 may fail for you, because this is relative, clear? So we normalize your marks, but here there is no normalization. This is absolute. So you have to make sure that you perform well on each of the CLOs, the minimum pass percentage, that is 40%. Now the recommended books for this course. So we have this Irrigation Engineering and Hydraulic Structures by Garg. This is given in your syllabus. So this book is a big book covering every aspect of irrigation engineering and discuss in detail the different hydraulic structures. For hydraulic structures, the other book that is given in your syllabus, that is Hydraulic Structures by Moffett. So this book is not available in the library, but it is available online. You can download this book. Now, irrigation engineering and hydraulic structures, we have currently 54 copies of this book available in our library. Maybe you can download this book from different websites, but if you are interested in the hard copy, we have 54 hard copies of this book in our departmental library. These are given in your syllabus. We have other books also that are very good. For example, we have Irrigation and Hydraulic Structures, Theory, Design and Practice by Dr. Iqbal Ali, a Pakistani writer, author. So he has written this book. It's available in the market also. If you are interested to keep a copy of this, you can purchase. And this is another book, Applied Irrigation Engineering. This is published from University of Agriculture, Faisalabad. This is in 2017. You can find the soft copy on the internet, or you can purchase from the market. It's very good book. The main idea here is that you will get some latest data about the water resources in Pakistan, the irrigation system clear. So you can get latest data from this book published in 2017. Now this irrigation and hydraulic structures, theory, design and practice, we have 21 copies available in our library. So you can issue this book from the library. 21 copies are available. Another book, that is Irrigation and Water Power Engineering by Pumia and other authors. This is also a good book. Similarly, we have Irrigation and Drainage Engineering. This is also a latest book published by Springer, and you can download this from the internet. It's very good book. This Irrigation and Water Power Engineering, we have 86 copies available in our library. Now another book which is also written by a Pakistani author, Iqtidar H. Siddiqui. So this is Irrigation and Drainage Engineering. This is also available in the market. You can buy. This is a good book, very comprehensively. All aspects of irrigation, all topics, they are explained. So this is also a good book. And another book is Irrigation Engineering by Sharma. Now you can see here most of the books are either Indian or from Pakistani authors also. We have books, for example, this one, Irrigation and Drainage Engineering by authors from developed countries. But the reason here is that the latest books of irrigation, either we have the British or the US, they mainly talk about the emerging technologies in irrigation. as I already explained, the sprinkle and trickle irrigation systems. So because in Pakistan, even today we are using the traditional methods, the infrastructure remains the same with very little improvements or modifications, and the irrigation methods still remain conventional. So that is why in that context, we need to follow these books. Clear? These are well suited when we compare the subject in the context of Pakistan. If you have any question, you can ask. Is there any question?
No, sir.
Okay, so let us take a break and then we will continue after the break. Thank you very much for listening.
Yes, sir.
Okay, thank you. Okay, so Bismillah Rahman Rahim. Now in second part of the lecture, we will study about introduction to water resources. Occurrence of water in space and time with a feasible potential to be put into multiple consumption and use, and for sustaining the environmental balance. Water, which is occurring in space and time and is not constant, you see that it varies the quantity from place to place and from time to time at the same place. But water occurs from place to place and time to time with a feasible potential to be put into multiple consumption and use. We have the water that is available from the different resources. So in this case, the same water we put into multiple uses. For example, we supply the water for drinking purposes. We supply the water for industrial purposes. We supply the water for agriculture purposes. So this is what actually it means, that the water which is available in space and time has the potential to be put into multiple consumption and uses. So water is life. We are using water for different purposes and for sustaining the environmental balance. For example, the water is flowing in rivers. So we use that water, we divert, we extract that water for different purposes. But we have to maintain certain minimum quantity of water also in a river. That is very crucial for survival of the ecosystem, natural ecosystems. That is known as environmental flows. We use the water. After usage of the water, you studied in environmental engineering, we have to treat the water before we release it to the point of disposal. This is important for sustaining the environmental balance, because the water which is used in our houses, so definitely it carries chemicals It is coming from cooking, washing. So we have to treat the water if it contains pollutants above the standards. Same is the case for the industries. So that's why you studied wastewater engineering, sanitary engineering. So we have water available on the surface of the earth, which is crucial for life to exist. We put it to different consumptions. And for sustaining the environmental balance. Water is a single resource. You see that it has no substitute. It is a limited resource. This we talk about the fresh water, which we are using for different purposes. Otherwise, we have a lot of water in the oceans, but that is not fit for use. So fresh water, it is a limited resource. Is it accessible to all, to everyone? In how much quantity? And what is the quality of the available water? Water has social, economic, and environmental value. Because we need water to survive. And you have studied before that communities, civilizations, they nourished along the banks of the rivers. So water has a social value. We supply the water to a community. We supply the water for agriculture purposes, and then we pay the charge for use of water. So water has an economic value. And that way money is actually used for maintenance of the systems that supply the water. For example, we use the water for hydropower production. So the electricity is supplied to the consumers, and then the consumers, they are charged for that. The water which is supplied to the agricultural land, the crops which are grown, those crops, they generate the income for the farmers. And the crops, they need water for growth. So water has an economic value and environmental value. As I said that for survival of the ecosystems, water is important. You see that when we discharge the water from our houses, we discharge it into the rivers. So the river kind of playing a role of absorbing that polluted water. Otherwise, that polluted water can create a lot of problems for the environment. So that's why water has an environmental value. A unique resource. Every organism, individual, and ecosystem on the planet depends on water for survival. Water impacts all aspects of life on the planet. You see that we use water for drinking, for cooking, for washing, for agriculture purposes, for hydropower production. So water impacts all aspects of life on the planet. Poor water management and water shortages can lead to disease. If there is shortage of water, it can lead to disease, malnutrition, insufficient food. Because if we have no water, we will not be able to grow crops and we will not be able to feed the population. So it can result in malnutrition. Poor water management also includes that it can lead to disease if water stays at a place for longer time. Then it can become a breeding place for mosquitoes. A simple example, and that's how it can lead to diseases. If we have water shortages, it can result into reduced economic growth because water is used for industrial purposes. Water is used for hydropower production. Water is used for agriculture production. So if we have water shortages or poor water management, it can result into reduced economic growth of a country. Social instability, because people can fight over the water, it can result into conflicts, particularly if the rivers which supply the water that are transboundary, means the rivers are shared by different countries. So it can result into social instability and conflicts. Just like Pakistan and India, we are sharing the waters of the river, and also this type of conflict exists in different parts of the world where we have transboundary rivers. And environmental disaster. So if we do not have enough water in our rivers, it can adversely affect our ecosystems. Water resources. There are three resources of water. We have the rainfall. So the rainfall is very beneficial in any area. Because of the rainfall, it nourishes the growth of the crops, plants, trees, and also the same water appears as runoff in rivers, channels. The same water infiltrates into the earth and recharges the groundwater reservoirs. So rainfall is important source of water. The second one is the surface water, which appears in the form of lakes and rivers. And the same surface water, it can result because of the rainfall or melting of the glaciers. For example, we have in the northern areas of Pakistan. Even if in an area there is no rainfall but the river flows, this water will be available in the form of surface water from the rivers. And the third source is the groundwater. which exist below the surface of the earth in the form of aquifers. And this groundwater, it can be pumped to the surface of the earth and then used for different purposes. So these are the three primary sources of water: rainfall, surface water, groundwater. Hydrological cycle, which you studied in detail in your hydrology course, it basically shows the movement of the water in a cycle. You can see here that we have oceans, and from the ocean we have evaporation. And the reason for evaporation is the sun. Because of the sun, evaporation takes place from the ocean, and when the water moves up in the atmosphere, cloud formation takes place, and then these clouds condense, they move inland, and that can result into the rain. And this rain which is coming on the surface of the earth, then it has different components. Some portion of the rain that is used by the plants, and then after using the water for growth, the remaining water, it is released into the atmosphere again, that is transpiration. So evapotranspiration is the evaporation from the plant and the adjacent soil. Evaporation plus transpiration. Similarly, the surface water that is coming, that can aid to the storages such as lakes or appear as surface runoff in the form of stream. And this stream can again drain to the ocean. Also, we can have snow on mountains, precipitation, a general term used. And then there can be sublimation. This snow is changing to the vapors without the liquid form. Sublimation. You can see here, this is one subcycle: rainfall, then evapotranspiration, again cloud formation, can be another subcycle. So you can see here the water moves in a cycle with subcycles. This is the hydrological cycle or water cycle. Beside the surface component, the water can infiltrate, and we have this infiltration. Infiltration is the entrance of water into the soil, and the opposite is exfiltration. And then the downward movement of the water, that is known as percolation. Infiltration is the entrance of water into the soil, and then the downward movement, that is known as percolation. We have deep percolation, if the water moves down and then it joins the groundwater, which represents the saturated water in the soil profile, no air, that is the groundwater. And then this groundwater can connect with the ocean, and you can see here the water goes back to the ocean, and this is how this cycle continues. And in hydrology, you study all the details of these different components of the hydrological cycle. The hydrologic cycle describes the continuous circulation of water throughout our environment as it moves from the oceans to the atmosphere and the land, eventually returning to the oceans once again. So it describes the continuous circulation of water throughout our environment. The hydrologic cycle is driven by the energy of the sun and the gravity of the earth. Because you see that the water flows in the stream, that is open channel flow, and the main component driving the flow, that is the gravity. And it proceeds endless. It is a continuous cycle with sub-cycles, with or without human intervention. So because of the human being, that the activities we carried out because of the dams that we construct, because of the pumping of the groundwater that we extract for different purposes and so on, this cycle continues with or without human intervention. The hydrologic cycle is also referred as water cycle. The hydrologic cycle is actually made up of a series of complex processes and storages. So you can see here that you study full course of hydrology on studying the different components in detail. For example, how rainfall occurs, the dynamics of the cloud formation, how we measure the rainfall. Then you studied the areal distribution of the rainfall, how you calculate the missing data. You see, a whole one chapter you studied in hydrology. Stream flow, you studied a full chapter. Groundwater is a specialty in itself. Evaporation, you studied a full chapter. How we measure the evaporation. Evapotranspiration. Infiltration is a full chapter, how you measure the soil infiltration. The global view, you can see availability of water. We have 96.5% water that occur in oceans. So this water cannot be directly used for different purposes. So the fresh water on which we are dependent, that includes the water in the rivers, the groundwater that we pump. So it is only 2.5% of the total water available on the surface of the earth. That is why we say that fresh water is a finite and vulnerable resource. It's not that we have unlimited of water available to us and we can use indefinitely. So you can see here fresh water on which we are dependent, 2.5%. And then this is the distribution of the 2.5% of the fresh water. Now the 2.5% out of the 100% total available water, this is the fresh water now. So if we make this 2.5% as 100% now, so out of this 2.5% available water, 68.7% is in glaciers. And 30% that is groundwater, which is also directly not available. We have to pump the groundwater. So it means that the water which is available, for example, in lakes or in rivers, that is just 1.2%. If we make this 2.5% 100%, so you can see here of that 100%, only 1.2% of water, that is the surface or other fresh water, that is directly available to us. And then this 1.2% surface water and other fresh water, you see the lakes, they contribute 20.9%. and the ground ice or permafrost, that is 69% of this 1.2%. So actually what we talk about normally is the rivers. This is what we talk about when we will discuss in Pakistan the irrigation system. Mostly we will talk about the Indus River and its tributaries. So you can see here the quantity of water that is available to us for different purposes, on which in the rivers we build the dams, we divert the water, and so on. You can see that how much the water is available globally to us for use directly. So the fresh water, which is 2% available of the total water, you can see here that great portion is frozen, and around 30%, that is the groundwater. So the surface fresh water only available is 0.3%, very small quantity. These figures can slightly different because the sources of these figures are different. So 2.5% fresh water but frozen. 97% is seawater, it is non-drinkable. So the fresh water that is available to us in the form of aquifers, you see large quantity of that is in aquifers in the form of rainfall, natural lakes, reservoirs, and you can see the rivers. The water that is available directly to us in the rivers. So we construct dams on the rivers. We divert the river water for different purposes, for agriculture purposes, and so on. That is why we say that in here you see that fresh water is a finite resource. We cannot say that water is available unlimitedly. Now we discuss about water resources in Pakistan. So in Pakistan, we are blessed with these glaciers in the northern parts of the country that supply water to the rivers flowing through the plains of Pakistan. We have rainfall in the country. The Indus River is the major river that is flowing. This river and its tributary is the lifeblood of agriculture in Pakistan. And we have the groundwater that we are pumping. You see here in our city in Peshawar here, so we are extracting groundwater and the quality is good. That's why without treatment we are supplying this water to our communities. And the same groundwater we are extracting for agriculture purposes also in Punjab. We are exploiting this groundwater for agriculture in addition to the canal water, clear, the rivers. So let us briefly discuss these components in detail. Pakistan has been blessed with a variety of water resources in the form of glaciers, seasonal precipitation that includes rainfall and snow on mountains, groundwater, and surface water. So first we talk about the glaciers. Significant part of the Indus River flow originates from Karakoram Himalaya, Western Himalaya, and Hindu Kush mountains. So the source of the Indus River, which is very important river, Indus River and its tributary, the source is in the north, the mountains. The glaciers carry great significance in the flow volume and timing of the Indus River and its tributaries. So these glaciers are very important. You see that the glaciers, they melt because of more temperature during the summer. So you will see that the quantity of water that is flowing in the Indus River, that is more as compared to the winter. This is common, clear? This is the reason that these glaciers, they melt during the summertime. And the Turbela Dam, it is normally full during that time when we have high river flows and the water is stored and is used for hydropower production. And during low flows, the same water is then released to meet the water demands. So these glaciers, they have great significance in the flow volume, how much quantity of water that is flowing in the Indus River and its tributaries, and the timing. The glacier runoff contributes approximately 24.1 billion cubic meter to the total annual flow of the upper Indus basin. This glacier runoff, it contributes 24.1 billion cubic meter to the total annual flow. So 17.3 billion cubic meter from the Karakoram Himalaya, 2.8 billion cubic meter from the Western Himalaya, and 3.9 billion cubic meter from Hindu Kush. These are the different mountain ranges we have in the north of the Pakistan. And actually these mountain ranges continue in north of Pakistan, touching the China border, and in India and Nepal. So these glaciers, these are very important. They are supplying water to millions of people in India, Pakistan, Bangladesh, Nepal. We are dependent on water from these glaciers. The second one is the rainfall. The regional distribution of average annual rainfall varies from less than 100 millimeter in Balochistan and Sindh provinces to more than 1500 millimeter in northern mountainous areas. You can see a lot of variation in the rainfall. We have less than 100 millimeter in Balochistan and Sindh to more than 1500 millimeter in the northern areas. So this is the reason why we have to artificially supply the water for agriculture purposes. Because of the non-uniform distribution of rainfall, about 70% of annual rainfall is received during the monsoon period. That is the months of July and August. You can see that in Pakistan, 70% of the annual rainfall that is received during the monsoon period. So in Pakistan, we have two seasons. One is known as the Rabi season. And accordingly, we have the Rabi crops. This Rabi season is from October to March. It is less than 50 millimeter in parts of Sindh and more than 500 millimeter in Khyber Pakhtunkhwa provinces. You can see here that when we have Rabi crops, if we are dependent on the rainfall, so you can see that less than 50 millimeter of rainfall occurs in parts of Sindh and more than 500 millimeter in Khyber Pakhtunkhwa. Similarly, the mean rainfall for Kharif season, which is from April to September, Kharif means the summer, clear. Rabi means the winter season, varies from 50 millimeter in Balochistan to more than 800 millimeter in northern Punjab and KPK. So this is the situation of the rainfall. You can see that the non-uniform distribution of rainfall. So that's why rainfall alone is not sufficient for agriculture purposes. If we are dependent on rainfall, it will be not possible to have enough food that can feed the entire population of the country. The extreme changing pattern of rainfall results in large variations in flows during the Rabi and Kharif seasons. Due to this severe aridity, about 92% of areas of Pakistan is facing extreme shortage of water and hence classified as semi-arid to arid. It means that Balochistan and Sindh, clear, those areas can be classified as semi-arid to arid land, where we have less rainfall. About 16.5 billion cubic meter of rainwater contributes to crops. In the Indus Basin irrigation system, this we will study in detail, the Indus Basin irrigation system. So 16.5 billion cubic meter of rainwater contributes to crops, which is only 13% of the average annual canal diversions. It means that the water which we are diverting from the rivers for agriculture purposes, the rainfall contribution is only 13% of that. So it means that the crops which needs water for growth, the rainwater only contributes 13% of the water that we supply through irrigation, artificial application of water to crops for full-fledged growth. So these figures are from this book, Applied Irrigation Engineering, published from University of Agriculture, Faisalabad, 2017. You will find these figures are given. So you can see here that the large variations in the rainfall in Pakistan, and also even if we have rainfall, you see that its contribution is very less. So this is the reason why we have irrigation. Irrigation is artificial application of water to crops. If we have rainfall that is sufficient, it occurs uniformly over all areas and at correct times. When plant need, we have rainfall, then rainfall alone would be sufficient for agriculture. Since that is not the case, as you can see in the context of Pakistan, so that's why we have irrigation. We have to artificially supply the water for agriculture. So you can see the importance of irrigation engineering in Pakistan. Another source is the groundwater. Groundwater provides an alternate water resource for agriculture. Why alternate? Because groundwater is not directly available to crops. If the water table is at or near the root zone, plants may be able to extract water for growth But if the water table is sufficiently below, plants will not be able to directly extract the water. Hence, we have to pump the water and then we have to supply it to the agriculture fields. It is estimated that around 33% of the world's population utilizes groundwater. So you can see here that it is a very valuable resource of fresh water availability to us for different purposes. Now, many countries such as Pakistan, India, they are intensively exploit groundwater to supplement the canal water. As we saw earlier, that rainfall is not sufficient. The surface water that is available, so there can be variations. For example, in Pakistan, the water that is available in the Indus and its tributaries are melting of glaciers. So during summertime, the glaciers melt, sufficient water may be available to meet the demands from the river flows. But in winter, the glacier melting will be very slow because of the temperature difference. So hence less quantity of water may be available during winter time. The alternative can be either have already stored the water in the dams and from there you supply the water, or you can pump the groundwater to supplement the canal water to meet the demands. The rice wheat region, central Punjab of Pakistan, is meeting 70% of their crop water requirements from groundwater. So you can see the importance of this source. In central Punjab, 70% of the crop water requirements are met from the groundwater. In Pakistan, most of the groundwater resources are stored in alluvial deposits formed by the Indus River and its joining tributaries starting from the Himalaya mountains to the Arabian Sea. So we have these groundwater resources because we have these glaciers since long period of time. So the water is flowing in these rivers and they carry the sediments, and then these sediment deposits and the water trapped below. You can see alluvial deposits, alluvium. Those are carried by the rivers. So these groundwater resources, these are stored in alluvial deposits that are formed by the Indus River and its tributaries, which run from the glaciers, Himalaya mountains in the north to the Arabian Sea in the south. The Indus Plain area is 1600 kilometers long and extends over an area of 21 million hectares. This alluvial deposited plain has extensive unconfined aquifer. So you studied in groundwater hydrology, confined, unconfined aquifer. Unconfined aquifer, which is the top surface of the water that is subject to atmospheric pressure. The top surface of the water that is water table. Unconfined aquifer, which is providing a supplemental resource of water for irrigation. This groundwater reservoir has been enriched by the direct recharge from rainfall, river flow and the continued seepage from the irrigation network of canals, distributaries and water courses since the last 90 years. So the groundwater recharge, the aquifers that exist, these are recharged from the rainfall. So the rainfall occurs, it infiltrates and ultimately joins the groundwater. The water flowing in the rivers, the water can seepage can occur, and the continued seepage from the irrigation network of canals. So we have unlined canals where the seepage of water can take place. So we have canals and then the distributaries and water courses. The difference is that of the sizes, clear? So the seepage can occur from these canals, distributaries and water courses, and they can refresh the groundwater reservoir. In Punjab and Sindh, about 79 and 28% of the area is underlain by fresh groundwater, which is used as supplemental irrigation pumped through tube wells. So you can see here why in Punjab groundwater is used for different purposes intensively. Surface water. The major sources of surface water contributing to the Indus Basin irrigation system are the snow melts and precipitation over the mountainous regions. So in our case, the rivers that we have are originating from the mountains in the north, and the source of water in the rivers, that is the snow melts and precipitation, either rainfall or snow over the mountainous regions. So that runoff water through streams and rivers is stored in the reservoirs or is diverted directly through canal systems to the agriculture fields for irrigation. So the water which is flowing in these streams and rivers, the Indus River and its tributaries, either directly we have canals, systems, we are directly diverting the water from these rivers, supplying the water to agriculture, or we are storing the water in the form of Torbela Dam, Mangla Dam, and so on. And then from those storages, we supply the water for different purposes, including agriculture. The Indus Basin irrigation system primarily comprised of 6 rivers, namely Indus, Jhelum, Chenab, Ravi, Sutlej and Beas. In Pakistan, however, the surface water resources, because of Indus Water Treaty, were limited to the water of the Indus, Jhelum and Chenab rivers only. As you might have studied, that there are primarily 6 rivers in the Indus Basin irrigation system: Indus River, Jhelum, Chenab, Ravi, Beas and Sutlej. But after 1960, because of the Indus Water Treaty between India and Pakistan, so Pakistan has full control only on the 3 western rivers, that is the Indus River, Jhelum River and the Chenab River. So we are utilizing the water of these 3 rivers. Considering the temporal distribution of water availability in the irrigation system, about 84% of the total annual river flow occurs during Kharif season, during summer time. 84% of the total annual flow occur during this time. And about 16% of the flow occur during the Rabi season, winter season. Clear? You can see here that the water which is available, 84% of the total annual river flow occurs during Kharif season. This is, you see, temporal distribution. In time, how much the water is available. And 16% during the winter season. So for winter crops, what we have to do? That is why we need to have irrigation system, so that we can store the water that is available above the demands, and the same water we can use during the time when the river flows are minimum or less water is available than the demands. That is why we have the importance of construction of dams. To regulate, actually, to redistribute this flow. Because of the dams, we are not generating water, it is just redistributing the water. You store the water during high flows and then you release the same water during low flows to meet the demands. So because of these, you see that we have to construct the dams. The crop water requirements, on the other hand, occur to the ratio of 3 to 5 between Rabi and Kharif. This is the crop water requirements, the crops that we grow during the Rabi and Kharif seasons. Thus, there exists incompatibility between the water availability and the requirements. Incompatibility. Particularly during Rabi season, which has partially been regulated through managed releases from the dams and other reservoirs. This is the reason why we have to manage the water. Through a network of dams and reservoirs and a network of canals, distribution, and this is the reason why we have irrigation and irrigation engineering. It shows that storing of water during high flows and releases during low flows through dams and reservoir is indispensable for sustainable agriculture. So it means during high flows we have to store the water. For that we have to construct the dams, and then during low flows in the river we have to release that water to meet the demands. This is indispensable for sustainable agriculture. Sustainable agriculture means that it meets the demands of the present population, and also it is available for the future population. You see that we constructed the dams, we have the full network of irrigation canals. So not only it is meeting the demands of the present population, but also for the future population. So this is how these are critical for sustainable agriculture. Next, we briefly discuss about the Indus Water Treaty. So far what we discuss is that water is important for sustaining life on the surface of the earth. We discuss different sources of water, and we discuss that the availability of water is finite. It's not that we have unlimited quantity of water is available to us. And also, even if some quantity of water is available, the distribution, the temporal distribution, that is not uniform also. Sometimes we have more flow available in the rivers, sometimes we have less flow. And also these rivers are transboundary. For example, the rivers that flow into Pakistan, they originate in India. So definitely India will use the water to meet its demands, and that can affect the water availability for Pakistan. So that's why in 1948, the India, they stopped the water flowing from its territory to Pakistan. And the two countries, they were on the verge of a war, water conflict, water war. After almost 10 years of intensive negotiations, so a treaty was signed in the year 1960 that is known as the Indus Water Treaty between India and Pakistan. And it talks about the sharing of the water between the two countries. The Indus Water Treaty is a water distribution treaty between India and Pakistan, negotiated by the World Bank to use the water available in the Indus River and its tributaries. This treaty was signed in Karachi on September 19, 1960 by the Indian Prime Minister and the President of Pakistan. The treaty divided the use of rivers between the two countries. The treaty gives control over the waters of the three eastern rivers, that is the Beas, Ravi and Sutlej, to India, while control over the waters of the three western rivers, that is the Indus, Chenab and Jhelum, to Pakistan. The treaty also guaranteed 10 years of uninterrupted water supply. During this period, Pakistan was to build huge dams, financed partly by long-term World Bank loan and also some compensation money from India. You see that the rivers, the three eastern rivers, India has full control to use the water, and Pakistan has control on the three western rivers, Indus, Chenab and Jhelum. So because the Ravi, Beas, these water also flows into Pakistan, if India completely stops, what Pakistan has to do? So in that context, Pakistan was to build huge dams so that if any water crisis arises, we are able to store the water and we can use that water to meet the demands, water demands. So three multi-purpose dams, Varsak Dam, Mangla Dam and Turbela Dam were built. A system of 8 link canals was also built. Link canal, we will study these in detail when we study about Indus Basin irrigation system. A link canal is actually the link between the two rivers. Let's say we want to divert the water from one river to flow into another river, we construct these link canals. So a system of 8 link canals was also built and the remodeling of existing canal was carried out. These were the measures that Pakistan need to take care in case of reduction of water because the control of India over the western rivers. 5 barrages and a gated siphon were also constructed under this treaty. The treaty allows India to use the western river waters for limited irrigation use and unlimited non-consumptive use for such application as power generation. That is why recently you might have heard the Krishan Ganga project, Baglihar Dam. These are all run-of-a-river hydropower projects. Because under this treaty, India is allowed to build the run-of-the-river hydropower projects. Run-of-the-river means that we are not significantly storing the water. We just utilize the head to generate the hydropower. Just like, for example, we have the Ghazi Barota hydropower project. In Ghazi Barota hydropower project, it is just a canal which runs from Ghazi to Barota. And their head is available, and we have installed 5 Francis turbines, and we are generating 1400 plus megawatt of electricity. So that is run-of-a-river project. So India is allowed to construct run-of-the-river projects for power generation. And you might have heard in the news recently, Pakistan has raised objections to this, but we are not very much successful on this front. This was between Pakistan and India because we are sharing the rivers. These are transboundary rivers. Also, we have the water fight or conflict between the provinces in Pakistan. So because Sindh and Balochistan are on the downstream, so they also demand water to overcome the water shortages. So there can be conflict between provinces, and it has happened. So in order to share the water between the 4 provinces of Pakistan, in 1991, the 4 provinces agreed on what is known as the Water Accord. In 1991, an agreement to share waters of the Indus River was reached between the 4 provinces of Pakistan in the form of the Water Apportionment Accord. This is known as Water Apportionment Accord. Apportionment means Taqsim. Apportion means Taqsim. Water Apportionment Accord. This was between the 4 provinces of Pakistan in 1991. In light of the accepted water distributional principles, the following apportionment was agreed. You can see here for Punjab, in the Kharif season, this much water should be available, 37.07 million acre feet. And in the Rabi season, 18.87 million acre feet, making a total of 55.94 million acre feet. For Sindh, you can see here this much in Kharif and Rabi seasons. For Khyber Pakhtunkhwa, 3.48 million acre feet during Kharif season and 2.30 million acre feet during the Rabi season. Addition to that, the water available for civil canals. What we mean by civil canals? In Khyber Pakhtunkhwa, we have canals that are maintained by government. But we also have canals that are maintained by civil society, civil community. These are known as civil canals. So additionally, this water is available. So this is the water distribution on which the 4 provinces of Pakistan agreed, and this is known as the Water Accord that was signed in 1991. So you can find a lot of detail about the Indus Water Treaty and the Water Accord from the internet, from different websites. Now, water use around the world, you can see here, if we globally see the picture, So for agriculture purpose, the use is 70%. Around the world, 70% of water is used for agriculture because we need food for feeding the population. For industries, 22%, and for domestic purposes, 8%. If we break this between developed countries and developing countries, so high income countries means the developed countries, you can Google that what we mean by high income countries, you will easily find the figures. Simply we can say the developed countries. You can see here that in developed countries, 59% of water that is used for industrial purposes, 11% for domestic, and 30% for agriculture. And in developed countries, as we study along, we study the different irrigation system. You see that they are using the latest technology to supply water for agriculture purposes. So consequently, you see that 30% of water that is used for agriculture. But in developing countries, low income countries, you see here that agriculture use the water, 82% of water is used for agriculture. For industries, 10%, and domestic, 8%. You see here that this is the reason. You see in Pakistan, the conventional methods of irrigation use a lot of water. We just flood the agriculture field. Not all water is used. That's why the irrigation efficiency is very low. You supply more water, but actually the plants use less water for growth during that time. So the water is wasted, and consequently the irrigation efficiency is very low. So industrial use of water increases with country income, going from 10% for low and middle income countries to 59% for high income countries. So we have studied about the water resources, the different sources of water, and then we studied the different sources of water in the context of Pakistan. So that's why we have water resources engineering. So what is water resources engineering? Water resources engineering is that branch of civil engineering concerned with maximizing the social and economic benefits associated with the world's water resources. You see, it deals with maximizing the social and economic benefits. The social benefits, we are supplying the water to the communities. The economic benefits, we supply the water to agriculture, land, food production to feed the population. We export the food items, hydropower production. We generate the electric power from water supplied to the consumers. You charge them. So we are trying to maximizing the social and economic benefits associated with the world water resources, while minimizing the adverse environmental impacts due to modifications to the natural environment. So because we are using the water for different purposes, then on the other side, because modifications are made to the natural environment, we also have to minimize the adverse environmental impacts. For example, we are using the water from our houses and from industries, and then we release it into the rivers. So we are polluting the rivers. The same water can go down into the soil and it can join the groundwater, and the groundwater can be polluted. Because we supply water to the crops, and also we use pesticides, fertilizers, and the same chemicals then dissolve in water, and as the water infiltrates into the soil down, it can join the groundwater and the groundwater can be polluted. So these are the adverse environmental impacts. So water resources engineering is that branch of civil engineering concerned with maximizing the social and economic benefits associated with the world's water resources while minimizing the adverse environmental impacts due to modifications to the natural environment. You see, when you construct a dam, so we bring modification to the natural environment. When you construct the dam, we actually regulate the river flow and it can affect the ecosystems. You see that because of construction of the Tarbela Dam, the huge reservoir, many villages were inundated and we have to resettle the people to other areas. Because of the Tarbela Dam, the seepage of water, the water table raised in Mardan, Sawabi, these adjoining areas, and that affect adversely the land productivity. So we have to then provide drainage of this water to lower the water table. So this is what we say, minimizing the adverse environmental impacts due to modifications to the natural environment. And then in this water resources engineering, then we cover all the aspects of water resources that you have studied so far, the fluid mechanics, hydraulics, hydrology, irrigation engineering, and so on.